Welcome to GATE 2025 solutions. In this video, we are going to discuss about GATE 2025 questions from the subject electric circuits from electrical engineering paper. Question number 1. This is GATE 1 mark question. The IV characteristics of the element between the nodes X and Y is best depicted by. Here a circuit is given consisting of ideal 1 amp current source connected in parallel with 1 kilo ohm resistor. Let's try to solve this question. Let's take the circuit. The current flowing through ideal current source is 1 amp. Let's represent this. The current passing from the node X to Y is IXY. From Kirchhoff's current law, the current flowing through the resistor 1 kilo ohm is IXY minus 1 amp. Let us represent the voltage across 1 kilo ohm resistor as VXY. Now applying Ohm's law to the 1 kilo ohm resistor, voltage across 1 kilo ohm resistor is equal to current flowing through 1 kilo ohm resistor into 1 kilo ohm. Rewriting the equation, we get IXY is equal to Vxy by 1000 plus 1. This is similar to the form y is equal to mx plus c, where m is slope. We have obtained the equation which relates voltage and current between the nodes x and y. Substitute a random value of Vxy and obtain the corresponding value of Ixy. Taking Vxy is equal to 0, we get Ixy is equal to 1. And similarly, taking Vxy is equal to 500, we get Ixy is equal to 1.5. Since the equation is similar to y is equal to mx plus c, the graph will be having a straight line which is having an intercept c and having slope m. Now take these 2 points and draw the straight line graph. We get this. Comparing with the given options, option B is correct. Question number 2. This is GATE 1 mark question. A nullator is defined as a circuit element where the voltage across the device and the current through the device are both zero. A series combination of a nullator and a resistor of value R will behave as a. From the given statement, a nullator is a circuit element whose voltage and currents are zero. Let us draw this. Now connecting a resistor of value R to the nullator, we get this circuit. Let IT be the total current flowing through the circuit and VT be the final output voltage across the series combination of nullator and the resistor. From the circuit, it is clear that IT is equal to 0. Since I is equal to 0 amps. From Ohm's law, we can write Vt is equal to It into R. Since It is 0, Vt is also equal to 0. Again, we have obtained that total voltage and total current as 0. Therefore, this circuit will again behave as nullator. Option B is correct. Question number 3. This is GATE 2 mark question. A switch is closed at t is equal to 0 seconds. The time in seconds the capacitor takes to charge to 50 volts is. This question is from transients. For any transient problem, we need to find initial value, final value and the time constant. Let's calculate those values. Let us start with initial value. If you observe carefully, before the switch is closed, the circuit is at steady state. We know that at steady state, current flowing through the capacitor is 0. Therefore, current from 3 amp source flows only through 25 ohms resistor. From Ohm's law, we can calculate voltage across 25 ohm resistor. Voltage across 25 ohm resistor is equal to current flowing through 25 ohm resistor, which is 3 amps, multiplied with resistor 25 ohms, which is equal to 75 volts. The initial voltage across the capacitor is equal to 100 volts minus 75 volts, which is equal to 25 volts. Therefore, initial voltage across capacitor is equal to 25 volts. Keeping this aside, now let us calculate the final voltage across capacitor. After the switch is closed, again a steady state is formed. The current from the 3 amp source only flows through the short circuited path because it is having zero resistance, and also the 25 ohm resistor becomes redundant. At steady state, current flowing through the capacitor is 0, therefore final value of voltage across capacitor is equal to 100 volts. Now we have obtained initial value and final value of voltage across capacitor. Now let us calculate time constant. We need to calculate time constant after the switching action is done. After the switch is closed, the 25 ohm resistor becomes redundant because no current flows through it, as the 3 amps current flows through the short circuited path through the switch. To calculate time constant, we need to replace the sources with their internal resistances. The internal resistance of voltage source is 0, so let us represent the voltage source with short circuit and calculate the resistance seen through the capacitor. Resistance seen through the capacitor is 2 ohms. We know that for RC circuit, time constant is equal to R into C. Therefore, time constant tau is equal to resistance 2 ohms multiplied with capacitance 5 farad, which is equal to 10 seconds. Now let us solve the remaining question. Let us recall the transients formula which is used for first order circuits. For first order circuits, voltage across capacitor or current through the inductor is equal to final value plus initial minus final value multiplied with e power minus t by tau. This is standard formula. For this problem, we need to calculate voltage across capacitor. Therefore, Vc of t is equal to final value plus initial minus final value multiplied with e power minus t by tau. In the question, it is asked to calculate the time that capacitor takes to charge to 50 volts. Therefore, let us take voltage across capacitor is equal to 50 and substituting in the formula we get 50 is equal to final value we have calculated which is equal to 100 plus initial value minus final value which is equal to 25 minus 100 multiplied with e power minus t by tau. Tau is time constant which is equal to 10 seconds. From this equation we need to calculate the value of t. Let's do this. Solving this equation step by step, we get time taken for capacitor to charge to 50 volts is equal to 4.05 seconds. Question number 4. This is gate 2 mark question. Consider two coupled circuits having self-inductances L1 and L2 that carry non-zero currents I1 and I2 respectively. The mutual inductance between the circuits is M with unity coupling coefficient. The stored magnetic energy of the coupled circuits is minimum at which of the following value of I1 by I2. This is multiple select question. First, let us draw circuit based on the given data. Now, let us write the equation for stored magnetic energy, which is equal to half L1 I1 square plus half L2 I2 square plus M I1 I2. We know that self-inductances L1 and L2 and mutual inductance is constant. Here, the variable parameters are I1 and I2. In the question, it is asked to calculate when the minimum stored magnetic energy occurs. Therefore, by using the concept of maximum and minimum from engineering mathematics, here there are two variables I1 and I2. We need to differentiate and equate them to 0, which is dou E by dou I1 equal to 0 and dou E by dou I2 equal to 0. Let's solve for this. Taking the first equation dou E by dou I1 and doing partial differentiation, we get L1 I1 plus M I2 equal to 0. From this, we get I1 by I2 is equal to minus M by L1. Similarly, solving for dou E by dou I2 equal to 0. Doing partial differentiation, we get L2 I2 plus M I1 equal to 0. From this, we get I1 by I2 is equal to minus L2 by M. Now, let's go through options and mark the correct options. Option A and option D are correct. Regular questions has completed. Now, let us solve the gate extra buffer questions given in gate 2025 master question paper. Question 1b, this is gate 1 mark question. A coil of inductance 100 millihenry and series resistance 100 ohm is connected across 20 volts 1 kHz supply. The quality factor of the coil at 1 kHz is, we know that quality factor is equal to omega L by R, which is a standard formula. In the question, the values of L and R are given. We need to calculate the value of omega, which is equal to 2 pi f. Substituting the frequency 1 kHz, we get 2000 pi radians. Therefore, quality factor is equal to omega 2000 pi multiplied with inductance 100 milli divided by resistance 100 ohm, which is equal to 2 pi. Therefore, option B is correct. Question number 1c, this is gate 1 mark question. A device which works with single phase 50 Hz AC yields the following measurements at its terminals. Voltage is equal to 141.4 at an angle minus 10 degrees and current is equal to 0.7 at an angle minus 55 degrees. The power factor of the device is. Now let us take the device which is connected to single phase 50 Hz AC supply. Now let us draw phasor diagram. First let us take voltage. V is equal to 141.4 at an angle minus 10 degree volts. Now taking current, I is equal to 0.7 at an angle minus 55 degrees. To get the power factor, we need to calculate the value of theta, which is the angle between voltage and current. Theta is the angle between voltage phasor and current phasor. Theta is equal to minus 45 degrees. If we calculate in the opposite way, we get theta is equal to plus 45 degrees. We can take the angle either way. There will be nothing change in the answer. We know that power factor is equal to cos theta, which is equal to cos of 45 degrees, which is equal to 0.707. Question number 1D. This is gate 1 mark question. We need to calculate the current I in the circuit shown. To solve this question, one may directly apply mesh analysis or nodal analysis, which makes the problem complex. To make this problem easier, let us first reduce the given circuit by using source transformation techniques. Now let us solve this using source transformation technique. If you observe the circuit, 6 amps ideal current source is in parallel with 1 ohm resistance. If we apply source transformation to this, we get a 6 volts voltage source in series with the 1 ohm resistor. Now let us again further reduce the circuit. We can represent this branch as a 2 ohm resistor connected with a 2 volt source. Here the polarities of voltage source are important. Now let us take this circuit and find the value of I. Taking this as node V, applying nodal analysis to this node, we get V minus of minus 2 by 2 plus V minus 10 by 2 plus V by 3 is equal to 0. Upon solving this equation step by step, we get V is equal to 3 volts. To calculate the value of current I is equal to voltage by resistance, which is equal to 3 by 3, which is equal to 1 amp. Therefore, current I in the circuit shown is 1 amp. With this, all the electric circuit questions from GATE 2025 electrical engineering paper has been solved. Thank you for watching.